Hello, everybody. I will be starting the WA2 revision event now. Okay, it's 4 o'clock. So, to start off, a simple introduction about myself. I am Mr. Clarence, and actually, I have a lot of students actually say that I look like I'm in my 30s, but actually, I'm only in my 20s. I'm currently 23 years old, and I have about 3 to 4 years of teaching experience. I'm currently a student in the National University of Singapore, specializing in finance. So every year I take about 30 students, and I've been teaching since I was in NS when I was 19 years old. So every year my students that are taking national exams will usually have a distinction rate of about 70 to 75%, and most of them have actually a significant improve from their previous exams. So usually they start off with the range of about C5 to C6, and they usually end up with A2 or A1 for their national exams. So to share more about Overmug, we have actually 7 locations across Singapore with 3 main branches. So we have also a Telegram channel for O-level students and also A-level students. So for our location-wise, we actually have our main branches are in Bukit Timah, Marine Parade, and actually Kovan. So this Serangoon over here is actually shifted over to Kovan. So these are our 3 main branches, and our subsidiaries are actually the other 4 locations over here. So this is our new Bukit Timah Center, which I'm currently at now. It's right above Asari Affair. So it's a 2 minutes away, 2 minutes walk from Tangkaki MRT. And this is our Kovan Center, which is a short distance away from our Kovan MRT as well. So this center is already up and running from January 2024. So there are already lessons being held there. So what our center believes in is actually consistent hard work over a long period of time, which is also what I believe in when I was a student and also now when I'm a tutor. So I believe that as long as you put in the consistent hard work day by day, you will be able to see the improvement. So I don't need you to go through like 10 math questions in one day. If you can practice 1 math question or 2 math questions every day for 10 days consistently, you will definitely be able to see the improvement. Because the thing about A math and E math, okay, more of A math is that the workings and the steps for every questions are actually roughly the same. So every topic that you face, be it in this case polynomials and partial fractions, the steps are always roughly the same. Just need to understand and know when to apply and how to apply the different formulas. So actually, it can be very easy for you to score and do well in as long as you put in the consistent hard work. So our center provides weekly worksheets, notes, revision papers, pop quizzes, and so forth for you to practice and help you improve in your results. We also have welfare. We have very good welfare with pizza parties. We order bubble tea for our students. And we also have a pantry that is in our every center whereby students can enjoy the free snacks during lessons. Okay, more importantly, you can always come into our center to study on your own if you want to. Or you can come here anytime you want, 24 hours. So as long as you want to come study, you can always ask the teachers for the passcode if there's nobody inside. So you can study inside the center and just treat it as your library for you to do your homework and to study. Okay, so these are our tuition rates for O levels. So all of you should fall under this O level category. Okay, so now let's just get started with our WA2 result, our WA2 revision events. So the document is actually shared in the channel, in the chat. So you can access the Google Drive to look at the materials. Okay, if you are shy and you're shy to speak up in the call, you can just type in the chat if you have any questions for me. But before I start, can you all react to this? Can you all give me a thumbs up if you have the worksheet from the Google Drive? Okay, thumbs up, thumbs up, thumbs up, thumbs up. Tanishka and Jaylin, do you have the worksheet? Is in the Google Drive link on the chat. Okay. Okay, I've actually just sent you another link so you can see whether you can access the files. Okay, it should be Sec 3A Math. We are gonna cover polynomials and partial fractions, which I believe are the most common topics tested for the Sec 3 WA2 this time around. Okay, I'll send the link once again into the group chat. So you can just open the chat and you will see the Google Drive with the materials inside. Okay, so give it about maybe 2 minutes. I will start in at 408. Okay, Tanishka and Jaylin, do you all have the worksheet now? If yes, please give me a thumbs up. Okay. Okay, good. So now everybody have the worksheet. So I will get started with our revision event today. So for start, our polynomials. Okay, when it comes to polynomials, there's only two main focus that we need to take note of is actually the remainder theorem and your factor theorem. Okay, so before we go on to remainder theorem and factor theorem, which I am sure all of you are very familiar with, polynomials are in fact an equation that is in this form, whereby my powers, my degree, okay? So in this chapter, you are going to be very familiar. You'll always see this word degree over here, okay? Degree. Okay, what does degree mean? Degree means your highest power. So for a polynomial, the degree is usually 3 and above, because if your equation has a highest power, which is x power 2, it is actually just a quadratic equation. So that will not be called a polynomial. Okay, so a polynomial is usually when your degree is 3 and above. So that's when you categorize it as polynomial. And in this chapter, you usually define polynomials with fx. Okay, why fx? Because later you will realize that fx, the moment you define fx, it can actually give you a lot of options like remainder theorem and factor theorem. So the most important thing that a lot of students forget is to define fx. They can get everything right, but the moment they don't define fx, you will not be given the full marks. So when you define fx, it means that when you sub x equals to -1, for example, in simple terms, you will just replace all the x with -1. Okay, this portion is very straightforward. Okay, you will make use of these substitution values when you use remainder theorem and factor theorem. Okay, and before we go to that, actually, we will cover slightly a bit more on long division, which is actually something that you learn in primary school. Just that in primary school, your long division involves numbers only. But when it comes to the polynomials, your long division involves algebra, where you have more than one polynomials. So let's say you have qx, rx, fx, gx. So fx, okay, is your polynomial. Gx is your divisor, qx is your quotient, and rx is your remainder. So if you want to write it in your long division form, this is how it will look like. Fx, when you divide by gx, you will actually get qx. And when you do your long division method, you will end up with a remainder, which is rx. Okay, so this is how it will look like when you do your working for your long division when it comes to this chapter on polynomials. Okay, At times you will be able you will have to make use of long division. So it will be good if you can do a simple recap on your long division methods. So in case you forget how to do long division. Okay. So as usual, if you have any questions, you can just type in the chat and I'll address the questions. Unless if you want to speak up and just ask your questions in during the Zoom, as I'm okay with that as well. So now we move on to remainder theorem, which is actually a very simple concept. So when your fx is divided by x minus a, the remainder is f bracket a. So how do we derive this? What's the concept behind this? Very simple. If I'm dividing by x minus a, how we make use of this long division algorithm? Okay, fx, I'm dividing by x minus a. So x minus a is my divisor. Qx is my quotient, and Rx is my remainder. So remainder theorem, as the name suggests, you are looking for the remainder. So in this equation, you can see that x minus a, which is my divisor, is multiplied by Qx, which is my quotient. And Rx over here is my remainder. So if you want to find out what's my remainder, I cannot have this over here. Because if I have this, I'll not be able to find out what's my remainder. So the only way to eliminate this is to make this 0. And since this is a multiplication of x minus a times qx, the moment this is 0, 0 times qx will just be equals to 0. So the only way that I can take out qx and x minus a is if I were to let a to be equals to 0, because a minus a is equals to 0. So in simple terms, this is the logic behind it. You want to eliminate your quotient and your divisor so that you will only be left with your remainder, which is what you are looking for when you apply remainder theorem. Okay? But in actual fact, in the exams or when you're practicing your work, you just need to remember when you are dividing by x minus a, you will let the bracket to be equals to 0. And then you will sub in that particular value in. So it's the same in the second portion when you're dividing by bx plus c. Same thing, you will just let your bracket to be equals to 0. So if bx plus c is equals to 0, bx is therefore equals to negative c, and therefore x is equals to negative c over b, which is exactly what you sub in into your fx. So this is what we were talking about initially, whereby you will sub x equals to a certain value. So because of the fact that you have defined what's fx, instead of writing fx now, you can just write f bracket negative c over b. Okay, so this is remainder theorem for you. Any questions so far? If no questions, can you all react with a cross or a thumbs up? Okay, if there's any questions, please just type in the chat. Don't be shy. Okay, you're here to learn, so don't be afraid to ask your questions. Next, in remainder theorem is actually the same thing as your, factor theorem is actually the same thing as your remainder theorem. Remember, in remainder theorem, we are finding what is the remainder. So in simple terms, if you are a factor, for example, when we do 6 divided by 3, we get 2. So when we do our long division 6 and 3, your remainder is 0. Okay, because 3 is a factor. So in factor theorem is actually the same as your remainder theorem. When you sub in the values, your remainder should be equals to 0 because it is a factor. So if you come and tell me that x minus a is a factor of fx, and if you were to sub in f bracket a, you don't get 0, then either your substitution is wrong or x minus a is not even a factor to begin with. Because if you are a factor, you shouldn't have a remainder. Okay, so remainder theorem and factor theorem, they mean the same thing. You are essentially doing the same thing. Whereby if you are dividing by x minus a, you just need to sub in x equals to a. Because you want to let x minus a to be equals to 0. Which means x is equals to a. So you will just replace, this was originally fx. So since you already know that x is equals to a, you just have to replace the x with a. And the remainder has to be equal to 0. So usually you will use factor theorem in the event whereby you don't know what is your fx completely. So you have an unknown such as maybe bx. Then you must find out what's the value of b. Once you sub in the value of a of x that you're gonna divide by, for example, in this case, x minus a. So let's say you sub in f bracket a. Okay, no matter what you type, no matter what you write down in your fx, it must come back to be equals to 0. So usually a is a number, it's a constant. So you shouldn't have any unknowns unless the question gave you an unknown such as like coefficient of x, you don't know, or coefficient of x squared, you don't know. So when you do remainder theorem and factor theorem, your x are all replaced with numbers. So you shouldn't be seeing any more x at the end of your equation when you derive your remainder. Okay, so now moving on to how to factorize a cubic equation. So over here, cubic equations, like what I mentioned, is polynomials. So it is always in the form of maybe ax cubed plus bx squared plus cx plus d. Okay, or maybe it can even go up to power 4, power 5, but those are slightly a bit more rare. Usually it's only power 3. So how do I factorize a cubic equation? Because at the end of the day, you will be learning on how to solve and factorizing a cubic equation. So on your calculator, I'm not sure what calculator model you use. I used a Casio FX96. So for those using Casio FX96 SG, okay, you can actually use your calculator to factorize your cubic equation for you. So let's say I have this equation over here, 2x cubed plus x squared plus okay, let's say we have this. Let's say we have this cubic equation. Okay, for example, 2x cubed plus x squared plus x minus 1. You have to learn how to factorize this equation. So over here, first step, like what I mentioned at the beginning, for you to even use remainder theorem and factor theorem, you must first define your fx. So your first step is to always define your fx. Okay, unless the question has already defined for you. Okay, then afterwards, the question here, the steps here, they meant substitute x with different values of a until f bracket a is equals to 0. So over here, what you are doing is actually your remainder theorem and factor theorem. Okay, because you are finding the remainder when you sub in different values of x. So for example, if you were to sub in x equals to 1 into my equation, do I get a remainder of equals to 0? Okay, because I'm supposed to get a remainder of 0 if it is a factor. Okay, so for example, I mentioned earlier, you can use the calculator to factorize for you. But you're not going to get a full marks if you just use calculator and factorize the equation and give me my 3 brackets. Okay, so just like a quadratic equation, when you factorize a quadratic equation, you end up with 2 brackets. So for a cubic equation, you end up with 3 brackets. Okay, so on the calculator, for those using this model, you just need to press mode 3, 4. Okay, those that are using FX97, okay, if you're using FX97, if I remember correctly, it should be menu 5, 2, 3. Okay, so you should see a screen that shows you ax cubed plus bx squared plus cx plus d. So a, b's, and c's, they are actually your coefficients of x cubed, x squared, x, and your constant. So let's say we use this as an example. Okay, 2x cubed plus x squared plus 2x minus 1. Using this as an example, okay, a is equals to 2, b is equals to 1, c is equals to 2, and d is equals to negative 1. So you will key all these values into the calculator, and what the calculator is doing is actually solving for you. Okay, this is an example that I just used lah. But let's say, okay, your calculator shows you x equals to 1, x equals to 2, and x equals to 3. Okay, let's say your calculator did that. If x is equal to 1, means my bracket has to be x minus 1. If my x equals to 2, means my bracket has to be x minus 2, and the last one has to be x minus 3. So what the calculator is doing is actually solving your cubic equations for you. And once you are able to derive your solution, you can actually factorize them into brackets. Okay, brackets means all this. Okay, because when x is equal to 1, 1 minus 1 is equal to 0. Therefore, the entire equation will be equal to 0. So, yes, the calculator can factorize for you. Technically, you can get the answer straight away. But you will not be given the full marks. So, this is when we call, in your textbook, they call this the trial and error method. Okay, I believe your teacher in school will also encourage you to do the trial and error method, which means since we already know that all these x minus 1, x minus 2, and x minus 3 are factors, you will pretend and you will say, let x minus 1 be a factor. Okay? Yes, I know it may sound a bit ridiculous, like you already know what's the answer, but why must you sub in the values, right? This is called the trial and error method because they want you to show that you understand factor theorem. Which means if I want to test x minus 1 to be a factor, you have to sub x equals to 1. Therefore, from here, you will sub f bracket 1. And when you sub f bracket 1, you replace all the x with values 1. Your remainder should be equal to 0. And when your remainder is equal to 0, it just means that it is a factor. So from there, once you're able to derive your factor, one factor, you can find the remaining factors using long division or comparison. Okay, so what do I mean by you can find the remaining? Okay, so for the methods to find the remaining factors, okay, how do I know that you will get a quadratic quotient over here, like what they say? Okay, because if my question is ax cubed plus bx squared plus cx plus d, for example, let's say this is my cubic equation, my polynomials. If I know that x minus 1 is a factor, I need to be able to have a x cubed. And right now, I only have a x power 1, which means naturally, for me to multiply x to get x cubed, I will be needing x squared. Which means, okay, so it can be, for example, ex squared plus fx plus g. Okay, because you need the x squared over here to multiply with x power 1 so that you can get x power 3. And as what you know, as long as you have an x squared, it's a quadratic equation. Therefore, you must always have coefficients for x and your constant. Okay, this is what we mean by comparison, which I will go through fully later in our practice examples. Another method you can consider is actually long division, because you know that x minus 1 is a factor. Therefore, if I take fx divided by x minus 1, you will be able to find the remaining factors without any remainder. Okay, before I go on to practice examples, if any of you have any questions, please sound off. If no questions, please react with a thumbs up. Yes, Jaylin, you have a question? Is it regarding the question that you messaged in the chat? Okay, so I go through again. So for this portion, I mentioned earlier, you can actually factorize your cubic equations using calculator. So if you're using the model FX96SG, the Casio one, which is the one I'm using over here, so you can see that this is the calculator. Okay, so for this model, you want to factorize a cubic equation using calculator. You just press mode 3, 4. Okay, when you press mode, you will actually see equation for 3. Okay, so you press 3, then you press 4, you will get the screen that shows you A, B, C, D. Whereas for the other method, if you use this calculator over here, FX97, which is the other calculator, which is not the one with blue buttons, it's mostly I think black buttons. Okay, for those, you will press menu 5, 2, and 3. Okay, so depending on which calculator model you use, you will be able to use the calculator to factorize a cubic equation. Okay, if no more questions, let me start with the practice examples. So for practice examples, right, you will see that in polynomials, you will ask a lot of, you'll see the same questions all over again. So you will always see questions that wants you to do remainder theorem or factor theorem. If not, you have to find values of A and B and factorize the equations. So when we look at this question, they already define fx for me, so I don't need to define again. Next, I know that I have a factor of 2x minus 1 and a remainder of b plus 2 when divided by x plus 1. So the question wants me to find what is A and what is B. Simple simultaneous equation tells me that when I have two unknowns, I must have two equations, which is why I have two pieces of information here. One is that 2x minus 1 is a factor. The other is that there is a remainder of b plus 2 when divided by x plus 1. So if you realize you have two unknowns and yet you are only able to come up with one equation, look at the question again to see if there's any missing information that you didn't use. Okay, so now for part A, if I want to find out what's the values of A and B, like what I said, two unknowns, I need two equations. So using the first piece of information for 2x minus 1, you will sub x to be half. How did I get half? Very simple. You let 2x minus 1 to be equals to 0. Means 2x is equals to 1, x is equals to half. So you replace all my x with half. So therefore you have 2 bracket half cube plus half square plus a times half plus 2. Okay, and then from here, you will be able to derive 5 over 2 plus half a. Okay, and the moment you get 5 over 2 equals to 5 over 2 plus half a, you know that a is a factor. If it's a factor, there's no remainder. So it will be equals to 0. Okay, because always remember what you're doing here is finding your remainder. And since this is a factor has no remainder. Therefore, my remainder 5 over 2 plus half a will be equals to 0. Which means half a is equals to negative 5 over 2. And therefore, a is equals to negative 5. So that's one unknown settled. Next, you want to find B. Okay, you want to find B, you have to make use of the other piece of information that you are given, which is it has a remainder of b plus 2 when divided by x plus 1. So when I'm dividing by x plus 1, you will sub x to be equals to negative 1. Okay, because same thing, you let x plus 1 to be equals to 0. So you replace all the x with negative 1. Okay, and you will have negative 2 plus 1 minus a plus 2, which eventually gives me 1 minus a. But wait, I already know what's a, right? From the previous equation, a is equals to negative 5. So therefore, I don't have to keep writing 1 minus a. You can just write 1 minus negative 5, which is 6. So when you're dividing by x plus 1, you're able to conclude that the remainder is equals to 6. And the question said that the remainder is b plus 2. Therefore, b plus 2 is equals to 6 and b is equals to 4. Okay, so this is the first type of questions where you know what is a factor and you know what's a remainder, but you don't know what's the full polynomial. So in this case, I don't know what is a, therefore I don't know what is my full polynomial. So you will be asked to find the unknowns like that using remainder and factor theorem. So you just have to sub in, and 90% of the time you are doing simultaneous equation because you have two unknowns. So for part B, you need to fully factorize fx. So fx is now given by 2x cubed plus x squared minus 5x plus 2. Okay, because I already know what's a, so you don't want to keep writing a. And one thing I know about fx is that it has a factor of 2x minus 1. So I mentioned before, the moment you are able to derive one factor, you can find the remaining using two methods, either by long division or by comparison. So let me go through the first method first, okay, which is comparison. Okay, so I personally prefer comparison because it is faster and you will not make as much careless mistake and it's less tedious. So it's not that time consuming. When I mean comparison, you compare your fx with your factors. So on the left hand side, you write down your fx. On the right hand side, you write down your factors. So I already know that one of my factors is 2x minus 1. And since, like what I mentioned before, if you have an x cubed and now you only have x, to make sure that both sides has the same power at the end, you will need a quadratic equation. Okay, so that my x power 2 with my x power 1 will give me my x power 3. So that's why I have a quadratic equation for my missing factor. When I say comparison, okay, you compare the coefficients of your variables. So the easiest way is to compare the highest power and the constant, because you can see that you have three different unknowns over here. So to start off, when you compare highest power, which is x cubed, okay, this method will always work. Okay, you always start from the highest power and the constant. On the left hand side, your x cubed is 2. On the right hand side, to get x cubed, you need to have 2x times ax squared, which eventually gives me 2a x cubed. Then from here, technically, you can just ignore the x cubed and you will be able to derive 2 is equals to 2a. Therefore, a is equals to 1. Finish. Okay, so this is why I say comparing the highest power is the easiest, because there is only one possible combination that will get x cubed on the right hand side. Next, okay, after you are done with the x cubed, you compare constant. Okay, when you compare your constant, on the left, my constant is 2. On the right, to get my constant, it will be -2 times c. Okay, because c is a constant. -1 times c, therefore c will just be -2. So this is why I say comparison is what I always encourage, because just by writing 5 lines, I solve 2 out of 3 unknowns already. Okay, last one, to find b, you can choose either. So right now you already chose x cubed and constant to compare. The last one, you can just choose either x squared or x. So I will choose x squared. Okay, you can choose x also, you will get the same thing. So now by comparing x squared, on the left, I only have 1x squared. On the right, to get x squared, I can have 2x multiplied by bx, which gives me 2b x squared. And I also have -1 multiplied by ax squared, which gives me minus ax squared. From here, you can combine and you have 2b minus a bracket x squared. Same thing, you can ignore the x squared and conclude that 1 is equals to 2b minus a. But you also know what is a. A is 1. Therefore, you can just write 2b minus 1. Hence, 2b is equals to 2 and b is equals to 1. Okay, so from here, comparison, you can easily find out what's my a, b, and c. And therefore, you can conclude that 2x minus, and that fx is equals to 2x minus 1, followed by x squared plus x minus 2. Okay, so for this portion, negative ax squared because this is negative 1. Negative 1 multiplied by ax squared, and that's how I get negative ax squared. Okay, at the end of the day, you are adding all the coefficients together, correct? But because you are adding a negative number, therefore you can just write minus straight away. Okay, so from here, once you are able to derive your quadratic equation, you must always remember to factorize. So you will be able to factorize again x plus 2, x minus 1. Okay, then from here, this is your final answer. Remember, this will not be your final answer because you want to factorize fully. And when you factorize until a quadratic equation, you are not factorizing fully yet. So your quadratic equation, you must factorize further and get 3 brackets, as what I said at the start. For polynomials, if it's x cubed, you will have 3 brackets. Quadratic equation x squared, you only have 2 brackets. So this is the first method, comparison. Okay, let me go through the second method. So I'll erase my part A workings and I'll use the space at the top to do the long division method. Okay, but I believe if you understand comparison, I don't think anybody will want to do long division because it is too tedious. Okay, long division. So I will use my fx, which is 2x cubed plus x squared minus 5x plus 2. And since I know that 2x minus 1 is a factor, you will divide by 2x minus 1. Okay, so when I do long division, recap, start from here, 2x cubed, divide by 2x first. That will give me x squared. Afterwards, x squared over here will multiply with this. So you will subtract away whatever the product is, which in this case is 2x cubed minus x squared. Then from here, when you simplify, you will have 2x squared, bring down x minus 5x. Then next, 2x squared divided by 2x, you get x. So same thing, you will minus 2x squared minus x, which means you will have minus 4x. Bring down the plus 2, and then minus 4x divided by 2x, you actually get minus 2. And then you multiply back, you will get minus 4x plus 2, which therefore gives you a remainder of 0. You should get a remainder of 0. If you don't get a remainder of 0, it means your long division is wrong. Because you already know that 2x minus 1 is a factor. It is a factor. So there is no way you will get a remainder. So therefore, this is my quotient. I can conclude that fx okay, so you can conclude that 2x minus 1 and x squared plus x minus 2 like this. So it will be the same as what I have with my first method. So always remember to go and factorize fully. So don't waste your effort. You write all the way until here already, you don't factorize fully, you're not going to get the full marks. Okay, so a student actually asked a very smart question. They asked me, what if the question said x? Okay, so I sidetrack a bit. What if they say the question say x is a factor? So very simple. Using the example that I said just now, fx equals to my divisor times quotient plus my remainder. Okay, in case you don't remember don't know what I'm talking about, I'm talking about this portion over here. Okay, whereby I have my divisor, quotient, and my remainder. So now in this case, if they say x is a factor, if x is a factor, you will divide by x. So therefore, my divisor will be x. So it will be x times quotient plus remainder. And since you want to find what's the remainder, you don't want to have this portion over here. So if you don't want to have this portion over here, you must make this to be equal to 0. And the only way that this portion will be equal to 0 is if you have 0 times quotient. because there's no way quotient can be equal to 0. So the only thing that can be 0 is your x. So in this case, you will sub x to be equals to 0. So if the question say x is a factor, or the question say you are dividing by x, you will sub x to be equals to 0. Okay, so just always remember the bracket or the whatever you're dividing by has to always be equals to 0. Okay, you follow this rule, you will never go wrong. Okay, so now back to the question. Now I factorize in part B already. Part C is actually very simple. They say hence solve fx to be equals to 0. Part B I factorize, I know fx is equal to these three brackets. So I'll have 2x minus 1, x plus 2, and x minus 1 to be equal to 0. Okay, same like quadratic equation. For your equation to be equal to 0, as long as one of these brackets is equal to 0, the entire equation will be equal to 0. So therefore, I'll have x equals to half, or x equals to -2, or x is equals to 1. Finish. Okay, so for part C, it's very direct. So from here, you can tell if the question asks me to solve fx equals to 0, you have to factorize first. You factorize into three brackets already, you are able to find out what is the solution. Okay, if no questions, I will move on to the next part. So just recap a bit. Remainder theorem and factor theorem, they actually mean the same thing. What you're doing is you're subbing in a value of x into fx. So for factor theorem, because you know it's a factor, there is no way you will have a remainder. Therefore, your remainder will be equals to 0. Okay? For remainder theorem, when you sub in a value of x, you evaluate your equation, the value that you have in the end, that is known as the remainder. So if you are a factor, naturally your remainder should be equal to 0. Okay, so for the next question, same thing, we are finding the values of a and b. So actually, I want to go through a question whereby you don't know what is, okay, so I will skip the questions in between because the questions are actually for students to practice, but we won't be able to go through everything in this session. So you can go back and try. If you need the solutions, it will be uploaded after the session as well. So you don't need to worry that you don't know, you won't know whether your marks are, your answers are correct or not. Okay, so the solutions will consist of your workings as well. So you don't need to worry whether about not understanding. Okay, so the main focus here today is actually I want to go through the different kinds of questions that you'll be seeing in the exam. Earlier, that kind of question, what you are doing is you are solving for the unknown in the question, okay, using remainder and factor theorem. Question 5 is actually another kind of question that you can see or you can expect in your exams when your teachers are bored of testing remainder theorem and factor theorem. Okay, this tests your understanding on polynomials. So in this question, it said that this is equals to this entire equation. So you have 4 unknowns that you want to solve. I said before, in simultaneous equation that you learn in Sec 2, 2 unknowns, you need 2 equations. 4 unknowns, you will naturally need 4 equations. But that sounds too tedious already. 4 equations is too much for you to handle. So how do I make sure that I don't deal with 4 unknowns? Because honestly, 4 simultaneous equations, you will have to keep doing a lot of substitution, elimination, then you can eliminate. The goal here is to find A, B, and C, and D. Very simple. If you have learned partial fractions in school, you will know that this method called elimination. Okay, what do I mean by elimination? All of these are products. This means 2a times x squared minus 4 times bx plus 1. As long as one of these is equal to 0, the entire equation will be equal to 0. The moment the entire equation is equal to 0, you will no longer have an A or a B. Then you're only left with C and D. So you use this method and you can slowly find what is my A, B, C, and D. So first thing first, I want to make my first few portions equals to 0. I want to find D now. So to make sure I find D, I don't want A, I don't want B, and I don't want C. In this portion, if I let x to be equals to 2, x squared minus 4 will be equals to 2 squared minus 4, which is equal to 0. The moment a bracket is equal to 0, everything is gone. No more already. If this is also x equals to 2, means I'll have 2 squared minus 4, which also gives me 0. So this portion also equals to 0, which means I'll only have 0 plus 0 plus 2d, which means the only unknown I have now is 2d. So to do that, you write down sub x to be equals to 2. On the left hand side, you will sub in x to be equals to 2. On the right hand side, you already know that you are left with nothing other than 2d. So since you are able to derive this equation, you just need to key in the calculator for the left, evaluate, and you'll get 14 equals to 2d, which means you can conclude that d is equals to 7. Okay, so that is one unknown solved. Next, you settled d already. You want to remove other things, but you realize actually, if you want to remove, you only can remove this portion. Why? Because when remember your special identities, x squared minus 4 is actually x minus 2 and x plus 2. Just now we're summing x equals to 2 over here. That's why this is equals to 0. And that's why this is also equals to 0. Now, if you were to sub x equals to negative 2, only this will be equals to 0. This will not be affected. Therefore, I will have on the left 8 bracket negative 2 cubed plus 4 bracket negative 2 square minus 26 bracket negative 2 minus 14. On the right hand side, since x plus 2 will be equal to 0, this entire portion that I highlight in green is gone. It will be equals to 0. Okay, because when you sub x equals to negative 2, x squared minus 4 is equals to 0. Then you will be left with c bracket negative 4 minus 4 plus 2d. Okay, why is it negative 4? Because it is negative 2 times 2. Because I sub x to be equals to negative 2. Then from here, you will get, on the left hand side, you will get minus 10. On the right hand side, you will get minus 8c plus 2 times 7. Because I know that d is equals to 7. Okay, then from here, this is negative 86 plus 14. Therefore, negative 8c is equals to negative 24. C is equals to 3. Finish. Okay, with that, you have 2 out of 4 unknowns settled. Next, for the next few, if you want to find the last 2 unknowns, very simple. Same thing, we go by elimination. Just now we take out A and B, that's how we can find C and D. Now we find C and D already. We are left with only A and B. And if you notice, B is attached to what? B is attached to X. So if I want to take out B, I should just let X be 0 so that it will be B times 0. Okay, B times 0 will just give me 0. So I no longer have a B, I only have A. So for my next substitution, you will sub X to be equals to 0. You sub X equals to 0 on the left, you only get negative 14. On the right, you will get 2A times 0 square minus 4 times 0 plus 1, followed by plus C. So C is now 3 times 0 minus 4 plus 2 times 7, because we know that D is equals to 7. Then from here, you can further evaluate this entire thing. and you will get negative 8a minus 12 plus 14, which means I'll have negative 8a to be equals to negative 16. Okay, and then I get negative 16, therefore a is equals to 2. So 3 unknowns settled. Now for the last one, I want to find b. Nothing else to eliminate already. So we go back to what we learned just now, which is by comparison. Okay, and if you notice, I always say just now, when you want to compare, you compare the highest power. So my highest power in this case is x cubed. So you compare x cubed. On the left, you have 8x cubed. On the right, to get x cubed, you actually have 2a times x times bx. Okay, which means it will be 2a times x squared times bx, which eventually gives me 2ab x cubed. So same thing, you can ignore the x cubed and you can conclude that 8 is equals to 2ab. And since I know that a is equals to 2, you can conclude that 8 is equals to 2 times b, which will allow you to have b is equals to 2. So therefore, your final answer, you have a equals to 2, b equals to 2, c equals to 3, and d is equals to 7. Finish. Okay, so if you see a question like this in the exam, you should be very happy because there's no remainder theorem used, no factor theorem used, no long division used. You are only comparing and you are only doing elimination. And the concept of elimination is very simple. You just need something to be equal to 0. So you can go and use your imagination and make sure you can have a bracket to have equals to 0. Everybody understand this portion? If understand, give me a thumbs up. Okay. For this portion, negative 8c is equals to negative 24 because you shift, you have this. So you shift this over, you have negative 8c equals to negative 10 minus 14 equals to minus 24. Okay, does that answer your question? If, yeah. Okay, so if no questions, I'll move on to the last portion. Okay, so for the last portion, we look at this. Okay, question 6. Okay, question 6 is the last form of question that you will most likely see in the exam. I'll cover this before I move on to partial fractions. So for this portion, the question didn't give me fx, right? The question told me that fx has the roots of this, and that fx has a remainder of 20 when divided by x minus 4, and a remainder of 72 when divided by x minus 5. So it is like your remainder and factor theorem questions, whereby you have to find what are the unknowns. But in this case, the difference is I don't know what's fx. Okay, I only know the roots of fx. So if my roots are negative 1, 3, and k, you can actually find your fx in terms of their brackets. If this x equals to negative 1 is a root, means it has to be x plus 1 inside. If this x equals to 3 is a root, means it has to be x minus 3. And the last one, if x is equal to k is a root, it has to be x minus k. Finished, as simple as that. So this is how you derive your fx. But we don't stop here. Why? Because the question never say that the coefficient of x cubed is 1. Meaning to say, I can have a coefficient in front. Okay? So please do not assume that the coefficient of x cubed is 1 unless the question says so. So from here, So how do I know this as well? Really, it comes with experience. Very simple. I say already, right? You have two unknowns, you have two equations. To have two equations, the questions must give you two information. If just now I don't have this A in front, I only have one unknown, which is K. One unknown, I just need one equation, which means I only need one piece of information. But yet, the question gave me two pieces of information, 1 and 2. So, trust me, the question will not anyhow give you information like that one. There is a use to it in this topic. It's very hard to trick you, especially in these informations. This is how I know that there has to be another unknown, which is always going to be the coefficient of x cubed. You can just throw it to the front because at the end of the day, when you expand, A will just be the coefficient of x cubed. So now I got two things to find, A and K. First information, fx has a remainder of 20 when divided by x minus 4. Therefore, you will have x to be equals to 4 because you want this to be equals to 0. Okay, so you will just have A bracket 4 plus 1, 4 minus 3, and 4 minus k, which will give me 10A times 4 minus k. Okay, and the question said that my remainder is equals to 20. So remember, remainder theorem, your final answer is my remainder. So this is equals to 20. Therefore, you can conclude that A times 4 minus k is equals to 2. Because I divide both sides by 10. Okay, I don't expand first because I don't know what information I can get. So no point expanding first. Okay, and then from here, next information that we can have is I have a remainder of 72 when divided by x minus 5. So I will sub in f bracket 5 and you have A bracket 5 plus 1, 5 minus 3, and 5 minus k, which will give me 12A times 5 minus k. And this is equal to 72, which means divide both sides by 6, divide both sides by 12, I will get A bracket 5 minus k is equals to 6. Okay, so now I got two information, equation 1, equation 2. So if I want to remove the A, very simple, you just take equation 2 divided by equation 1. Okay, so from here, on the left-hand side, this is my left-hand side. So I will have A bracket 5 minus k over A bracket 4 minus k. On the left, you will have this, which will have 6 over 2. Then from here, you can cancel out the A, which allows you to have 5 minus k over 4 minus k to be equals to 3. How did I get 3? 6 divided by 2 is equals to 3. From here, a lot of students will say, hey, I must do cross multiply. Actually, you don't need to do cross multiply because fraction means divide. Essentially, this fraction is just saying that 5 minus k divided by 4 minus k gives me 3. As simple as that. So if you want to solve for the unknown, both sides just to multiply by 4 minus k. Okay, don't need to do cross multiplication. You will get 5 minus k equals to 3 bracket 4 minus k. And then from here, you expand, you get 5 minus k equals to 12 minus 3k. You bring 3k over, you bring 5 over, okay? You will get okay, wait, I think I wrote something wrongly. Okay, wait, let me check with the question again. I think there is a typo in the question. if I'm not wrong. Okay, sorry guys, give me 1 minute to check.
I'm Peppa Pig. This is my brother George. This is Mummy Pig. And
Okay, I found a mistake. Okay, there is a typo to this question by right because there was an edit to the question. So let me share with you what the original question is like. Uh, okay, so this was the original question. Question number 2. Okay, over here. Okay, because there are some changes to the question, that's why. So from here, same thing, because the difference, what we did is actually we took out the coefficient of x cubed. So the coefficient of x cubed wasn't equal to 2. We took out this information. So we came up with another equation that gives me the coefficient of x cubed to be equal to 2. So by right, this equation should be able to get me that. Okay, so this was original question. If you actually go and think about it, if you sub a to be equals to 2, which is the coefficient, okay, you will realize that this is my equation, which means, okay, so which means if I were to, okay, let me switch back to, okay, let me switch back to the working that I had. So if you sub a to be equals to 2, you'll realize that 5 minus k is equals to 3. Therefore, k is equals to 2. Okay, so you will eventually get the same thing. Okay, because I wasn't able to get just now for a very simple reason. There was a typo with the working, so you need to have the original question which I showed you just now. Okay, at the end of the day, I think most importantly, you must understand the flow of the questions. So in this case, always never assume that the coefficient of x cubed is equals to 1. Okay, never assume unless the question said. So in this case, the question didn't say anything. So you cannot assume that the coefficient of x cubed is 1. You have to always take into account the coefficient of x cubed. So if the question never say, you can just let it to be equals to a over here. Okay, so with that, the rest of the polynomial question you can go and try. Essentially, question 2, 3, and 4, they are testing you on the same thing, which is remainder theorem and factor theorem. So you have to you have to understand and realize that the questions asked will always be the same, which means the steps taken will always be the same. So with that, I'll move on to partial fractions, okay, which is the next part of polynomials. So partial fractions is actually very related to polynomials because sometimes you'll be asked to factorize a polynomial first before you can go on to partial fractions. So before we start, we have to identify what's a proper fraction and an improper fraction. Okay, so over here, a proper fraction is when my degree of my numerator is smaller than my degree of my denominator. Okay, remember, I just now said degree means highest power. Whereas improper fraction is the opposite, whereby my numerator is more than or equals to. So take note of this equals to. So and even if they have the same power, it is considered an improper fraction. So an example you have is over here. X squared is still considered an improper fraction because the degree is the same. Next, for your partial fractions, your steps taken. Okay, first step is to always check if your fraction is proper or not. Okay, if it's not a proper fraction, you have to apply long division to convert into quotient plus proper fraction. This portion I'll go through later. Okay, when we go to example question, because using words, I think it can be a bit confusing. So next step is to ensure that your denominator is completely factorized. If it's not, you have to factorize on your own. So you have to factorize on your own. Okay, which is why I say polynomials and partial fractions are actually very closely related. The moment your denominator is a polynomial, you have to factorize using what you learn in polynomial, which is what I went through just now, the trial and error method, followed by comparison or long division, so on and so forth. Next, you will have to express your fractions as a sum of simpler fractions. Very simple. You have three different rules here. If you notice, you see two brackets here. Naturally, you will see two different fractions. Next one is the same as the previous one, just that now there's a square. The moment there's a square, you have to repeat. As the name suggests, it's called repeated linear factors, which is why you have to repeat. Just that one time got square, the other time got no square. Last thing, the pattern is always the same. Two brackets, two fraction. But now, because cx plus d cannot be factorized, so this portion, take note, cx plus d cannot be factorized. Okay, so that's why my numerator is different. My numerator is not the same as before. Numerator usually is numbers or constants, but in this case, it's bx plus c. Why? Because, okay, for partial fractions, the trick is if you cannot remember what are the fractions that you must write, just need to remember when you split into partial fractions, okay, degree of numerator is always one lower than degree of denominator. Okay, so if you notice all of the examples that I have over here, the pattern is always the same. Over here is x power 1. Over here got no x, so it's just x power 0. Same for this, x power 1, x power 0. You look at the rest of the examples, it's the same thing, except this one. This is an exception because it's a repeated linear factor. Over here, x power 2. Therefore, over here, 1 lesser than 2 is x power 1. You remember this trick? It's very hard for you to forget what are the fractions you have to separate into. After you have your fractions ready, you combine the fractions into a single fraction, which means in this step, over here when you combine, you must make denominator the same. Okay, once I make the denominator the same, you can compare your numerators. So goes back to your foundation of addition and subtraction of fractions. To combine, you must make the denominator the same. When the denominator is the same, you just need to compare the numerator. If no questions, can I have a thumbs up from everybody? Then I'll move on to the practice questions. Okay, so for the practice question, number 1, okay, I have this. So very lucky, the denominator factorized for you already. So you don't have to factorize the denominator. You only need to factorize the denominator if they didn't factorize for you, which 90% of the time, part A will ask you to factorize a particular polynomial. Part 2 will say, hence express the following as a partial fractions, which means my denominator is actually the partial fractions that you factorize in the previous part. So this is usually how the questions are asked. So normally you don't really have to factorize anything, they will give it to you. From here, the steps are always the same. 2 brackets, so I'll have 2 fractions. The first one, it will be a over 2x plus 1, because the denominator is power 1. So numerator has to be power 0. Next one, denominator is x squared plus 2. Since this is x power 2, on top has to be x power 1. Therefore, it will be bx plus c. Finish. Your first step, you don't identify your partial fractions, you cannot get started at all. Next, you want to make the denominator the same. Your denominator is 2x plus 1 times x squared plus 2. If this is only x squared plus 2x plus 1, means I need to multiply by x squared plus 2. So you will have a times x squared plus 2 over 2x plus 1 and x squared plus 2. Next one, I have bx plus c. And since my denominator is x squared plus 2, I am missing a 2x plus 1. I'll multiply by 2x plus 1. So numerator will also have 2x plus 1. Always remember, whatever you multiply in the denominator, you have to multiply to the numerator as well, so that the values don't change. At the end of the day, I can easily cancel these two and I'll get back my original equation. Okay, so don't forget to multiply by your numerator as well. So now, since my denominators are the same, I can just compare my numerator. So I'll have x squared minus 8x plus 5 equals to a times x squared plus 2 plus bx plus c, followed by 2x plus 1. Okay, so I combine my numerators and I compare them. Left hand side equals to right hand side. So now you want to start. Very easy. You can just either do comparison or do elimination. Okay, so just now when I go through one of the questions, question 5 in polynomials is comparison. So you have to always make use of comparison in these 2 chapters. Okay, it's the easiest and the fastest method. So over here, we always see if you can do elimination first. So as long as you can take out a few unknowns, you're only left with maybe 1 unknown, you can solve very easily. You can see that here is bx plus c times 2x plus 1. If I can make this equal to 0, bx plus c times 0 will just be equals to 0. So if I want 2x plus 1 to be equals to 0, x must be equals to negative half. So I will sub x to be negative half on both sides, and I will have negative half square minus 8 times negative half minus 5 equals to a negative half square plus 2. Okay, second part will just be equals to 0 because bx plus c times 0 is just equal to 0. So on the left, I will have negative 3 over 4. On the right, I will have 9 over 4 times a. So to find a, you take negative 3 over 4 divided by 9 over 4, you will get negative 1/3. Okay, then from here, next portion, you already settled A already. So you want to find out what is B and C. So you cannot eliminate anything else because x squared plus 2 will always be more than 0 because x squared is always positive. When you add a plus 2 to a number that's always positive, you will always be positive. Okay, so we have to do comparison now. Hey, wait, I copied the question wrongly. Okay, do not make the same mistake as me. Over here is plus 5, I wrote minus 5. So this should be plus 5. So everything must change. This is plus 5. So I don't think this is negative 3/4. This is (37/4). Okay, your A is equals to 37/9. Okay, sorry, I copied the question wrongly. It's not minus 5, it's supposed to be plus 5. Okay, so from here, next portion, we do our comparison. So when we do comparison, we compare the highest power first. As I mentioned just now, you by comparing, highest power is x squared. So you only compare the x squared. On the left, my x squared is this. On the right, my x squared can be A times x squared, followed by bx times 2x. So therefore, I'll have ax squared plus 2bx squared. Okay, then from here, you can just compare your coefficients. You can ignore the x squared. 1 equals to 37/9 plus 2b. Okay, because I know that A is equals to 37/9. So from here, you can derive that 2b is equals to negative 28/9. So b is equals to negative 14/9. Then now I must find the last unknown, which is c. So comparison, highest power, compare finish already, you compare your constant. On the left, my constant is 5. On the right, your constant is A times 2 and C times 1. So you have 2A plus C. And I know that A is equals to 37/9. So this means C is equals to negative 29/9. So these are all my answers. To present in your final form, very simple. A is a fraction, right? So by right, you will be writing 37/9 over 2x plus 1 plus negative 14/9x minus 29/9 over x squared plus 2. Okay, but you never ever write a fraction within a fraction. So all these denominators that you see over here, you can actually bring down. Okay, you can actually bring down to the bottom, which means you will have 37 over 9 bracket 2x plus 1 plus negative 14x minus 29 over 9 bracket x squared plus 2. Okay, so finish. So your steps are always the same. Check if it's factorized. If it's not, you have to factorize on your own. Okay, if they are factorized already, you can just start with the formulas. The formulas are these three at the top over here. Distinct linear, repeated linear, and irreducible factors, which means you cannot factorize. Make sure you understand these three formulas. If you find it very hard to memorize, just remember one thing. The degree of your numerator is always 1 lesser than the degree of your denominator when I separate. Okay, you remember that. The rest, honestly, is just addition of fractions, which is actually very simple. Okay, I don't think addition of fractions is an issue. Okay, if no questions, I will move on to question 2. Okay, there's a question. Okay, any questions, Jaylene? Okay, so I'll move on to the next portion. So in question 2, same thing, they factorize the denominator for you already. Make use of the formula that we know, 2 brackets. So same thing, by right, you only have 2 fractions. But because this is a square, it's also known as a repeated linear fraction. So you have a over 2 minus x plus b over 2x plus 3 plus c over 2x plus 3 squared. Okay, so from here, you will make use of, you have to make the denominator the same. So from now, you no longer, actually this step over here, in the previous question where I make the denominator the same, you don't even need to write this step. You can just go straight to writing numerators because the moment the denominators are the same, all you need to do is compare the numerators. So in this question over here, I will do that. My denominator has to be the same, which is 2 minus x and 2x plus 3 to the power of 2. So on the left-hand side, I have 12x, which is this. For the first fraction over here, I need to multiply by 2x plus 3 squared. In the second fraction over here, I must multiply by 2 minus x followed by 2x plus 3. Okay, because I need 2x plus 3 squared. And right now, this I only have power 1. So I need another one. For the last one, it will be c followed by 2 minus x. So what I'm writing here is actually my numerators when I make the denominator the same. Okay, which is the key. Your denominator must be the same before you can even compare. Next, the equation looks very complicated. We make use of elimination. We look at these two. If we were to sub x equals to 2, they will just be equals to 0, which means you no longer have any b or c. So on the left, you will have 12 times 2. On the right, you will have a bracket 2 plus 2 plus 2 times 2 plus 3 squared. So you have 24 equals to 49a. Okay, which means a is equals to 24 over 49. Okay, this is the first one. Second one, you want to eliminate one more thing. You let these two be 0, which means you have to sub x equals to negative 3 over 2. How I get negative 3 over 2? You let 2x plus 3 is equals to 0. It means the x has to be equals to negative 3 over 2. Okay, so on the left, you will have negative 3 over 2. On the right, since this is 0, this is 0, I'm only left with c times 2 minus negative 3 over 2. Okay, so on the left, I will have negative 18. On the right, I'll have 7 over 2c, which means c is equals to negative 36 over 7. Okay, then for the last one, nothing else to eliminate already. So we have to do comparison. So you always compare the highest power, which is x squared. So if you notice on the left, no x squared. So if there's no x squared, it means that my coefficient of x squared is 0. Because I don't have any x squared. On the right, you want to get x squared, it will just be a times 2x squared. So when I square 2, I get 4, so it will be 4a. Okay, afterwards, I'll have b times negative x times 2x. Okay, which means I'll have minus 2b. Okay, these are my coefficients of x squared. Which means since I know that A is equals to 24/49, it will give me 96/49 minus 2b. Therefore, B is equals to 48/49. Okay, then from here, your answer, replace all the letters with the numbers that you have solved. You will just have 24. Same thing, fraction, you can just bring down. Okay, so you don't write a fraction within a fraction. Numerator, you just bring down. Okay, so this portion very important because more often than not, your answers will actually have a fraction inside. Okay, which is fine. Don't need to worry too much about having a fraction. Just need to remember that you have to bring the fraction down. Okay, so everybody take a look at the workings. If no question, give me a thumbs up, then I'll move on to the next question. Okay, does anybody have any questions? Because I don't think I see a lot of thumbs up. Okay, so over here, okay, actually there's one tip that I want to share that I am quite certain most schools won't teach you, okay? Because it actually requires a bit of time when you're doing a question. So this portion, you just bear with me for a while. When the question say express the following in partial fractions, it just means that you are writing this in another form, which is this. So my question is, does the value of the equation change? Can you all type in the chat? Does the value of the equation change when I write the question in another form? Because when you express as partial fractions, all you are doing is actually just rewriting your question into another form, into simpler fractions. So can you all give me some responses on the chat? Just type in, do you think the value will change? Yes or no? Or if you don't want to type, then you either give me a thumbs up or a thumbs down. Thumbs up for yes, thumbs down for no. Okay, still no responses from anybody. Can I have some responses, please? Okay, I have one thumbs up. So my value should be the same. Okay, I have a few thumbs up. Okay, I have one thumbs down. So, very simple. Okay, what I'm trying to say here is, if you are only rewriting your question, which is the one over here, into another form, which is the one over here, in actual fact, your value actually doesn't change. It's just rewriting another form. You are not doing any addition, subtraction, multiplication, or division. So by right, how do you test in the exam whether your answer is correct or not? Okay, why I enjoy partial fractions when I was a student is actually very simple. I found a way to make sure that my answers will always be correct in the exam. Partial fractions, if you have done in practice papers or test papers, you'll realize that they are worth at least 4 to 5 marks. And 4 to 5 marks is actually a lot. So how to make sure the answer is correct? In the question over here, if you were to sub x equals to 1, you press in the calculator, you will see 12/25. Which means when x is equal to 1, my question has a value of 12/25. My answer, you sub x equals to 1. You press the whole thing in the calculator, which I did already. The calculator also shows you 12/25. So what does that mean? Is my answer correct? If the value is the same, if my answer is correct, give me a thumbs up. If my answer is wrong, give me a thumbs down. Okay? Okay, I see a few thumbs up. Okay? Exactly what I mean by how do you make sure your answer is confirmed correct. If the value never change, means your answer is correct. So in the exam, if you have the time, you go and sub in a value of x and check for your question and your answer to see whether the values are the same or not, because the value of the fraction shouldn't change. Okay, so this is just a tip from me to you to help you check in your exams. But only do this if you have time. If you don't have time, then no point. Okay. No questions? Let me move on to the next part. Okay, in question 3, part 1, you're expressing the following in partial fractions. So this is where the proper fractions and improper fractions come into play. Why do I say so? Because my degree over here is 3. Over here, you have x times x times x, which means your degree is also 3. So you have to do long division because this is an improper fraction. Okay, so before you can do long division, if you recall, when you do long division for algebra, you have to actually you cannot have so many brackets. You have to expand first. If not, you cannot do your long division. So for your denominator, when you expand this, you actually get x squared plus 2x plus minus 3 followed by x plus 4, which gives me x cubed plus 4x squared plus 2x squared plus 8x minus 3x plus 12. Okay, this will give me x cubed plus 6x squared plus 5x plus 12. Okay, so now from here, we will do long division because remember, if you look back at the steps of your partial fractions, your long division has to be applied when you have an improper fraction. And in this case, I have an improper fraction. Okay. So when you write your improper fraction, okay, wait, let me just change. This should be minus 12. Okay, so your improper fraction, numerator divided by denominator. So you have 2x cubed minus 3x plus 1 divided by x cubed plus 6x squared plus 5x minus 12. So when you do your long division, same thing, 2x cubed divided by x cubed. Okay, so it's an improper fraction because the highest power here is 3. The highest power here is also 3. So if my numerator and denominator have the same degree, it is considered an improper fraction. So on the notes in the first page, over here, okay, so if my degree of numerator is more than or equals to degree of denominator, it is considered an improper fraction. So remember to always check first. Okay, so from here, continue my long division. 2x cubed divided by x cubed, you will actually get 2. Okay, then you subtract 2x cubed plus 12x squared plus 10x minus 24. You will get, okay, so I don't have any x cubed, I don't have any x squared. So from here, you just get minus 12x squared followed by minus 13x followed by plus 25. Then you realize actually your long division stops here. Okay, because I cannot take x squared and divide by x cubed. Okay, so from here, how do I write my question in the form of a quotient and a remainder? So this is my question, 2x cubed minus 3x plus 1 over x minus 1, x plus 3, and x plus 4. Okay, my quotient is 2. So it will be 2 plus negative 12x squared minus 13x plus 25 over my denominator will be my divisor, which is what I have over here. Okay, so same as my original denominator, it will just be x minus 1, x plus 3, and x plus 4. Okay, so this is how you write your long division after you do a long division for partial fractions. Okay, so now you have only a fraction here. So this is what you need to do partial fractions on, because you only need to do partial fractions when you have a fraction. So this portion don't need to touch. Therefore, for our partial fractions, negative 12x squared minus 13x plus 25 over, you have 3 brackets, x minus 1, x plus 3, and x plus 4. So same thing, since I have 3 brackets, I'll have 3 fractions. So it's a over x minus 1 plus b over x plus 3 plus c over x plus 4. Okay, because all the degree of my denominator is 1. So next, when I want to make the denominator the same, I'll compare only my numerator. So I'll have a times x plus 3 and x plus 4, followed by b times x minus 1 and x plus 4, then followed by c times x minus 1 and x plus 3. Okay, so from here, if you have been listening from what I was doing all this while, you'll realize that I always like to do elimination instead of comparison first, because elimination is very convenient and very easy to understand. You make one bracket equals to 0, the unknown, the entire thing will just be gone. So, example, if I sub x equals to 1, this will be 0, this will be 0. So these two entire equation that highlight will be gone. So on the left hand side, I will only have negative 12, 1 square minus 13, 1 square plus 25 equals to a bracket 0 plus 3 followed by 0 plus 4. Okay, then from here, you will evaluate the left hand side, which gives me minus 12 minus 13 plus 25 is just equals to 0. Okay? No, sorry, you sub x equals to 1, so it's 1 plus 3 and 1 plus 4. Okay, then on the other side, it will just be 20a. Okay, and since the left hand side is equal to 0, a will just be equals to 0. Okay, next you want to solve for, so now technically you already know that a is equal to 0, right? So this entire portion will just be equals to 0. So I'm only left with the highlighted portion. So we continue doing some elimination. You sub x to be equals to negative 4. So that this portion will be equal to 0. So on the left, you will have negative 12 times negative 4 squared minus 13 times negative 4 plus 25 equals to, since this is equals to 0, I'm only left with c times negative 4 minus 1 and negative 4 plus 3. So same thing, you evaluate with the calculator. Left hand side will just be equals to negative 115 is equals to negative will be equals to 5c. Okay, so from here, c is equals to negative 23. Okay, 5c is because negative 5 times negative 1 is equals to positive 5. So I get c equals to negative 23. Next, you want to eliminate x plus 3 over here. So you let this be equals to 0. Okay, no point summing x equals to 1 anymore because both of these has x minus 1. So from here, you sub x equals to negative 3. When you sub x equals to negative 3 on the left-hand side, you have same thing, you will just sub in all these values. Okay, then on the right, you will be left with b times negative 3 minus 1, negative 3 plus 4. So on the left, you will have negative 44 equals to negative 4b, which means b is equals to 11. Okay, so from here you can conclude that your question, so you always go back to your question, which was this. Okay, so you don't just simply write your partial fractions, you have to include this plus 2 over here. Okay, then from here, your final answer will just be 2 plus b, which is b is 11 over x plus 3. C is minus 23 over x plus 4. Okay, finish. So if it's a plus negative, you can bring down the negative and have minus 23. Okay, that is fine as well. Okay, so same thing, if you were to key in calculator and check, you will get the same result. Okay, so in this case, it's a bit special. Why? Because a is equals to 0, which means somehow you will end up with 2 fractions. Okay, but why is it that you are ending up with 2 fractions? Very simple. If you look back at the question, which is this, this was my question. Okay, if you go and factorize your numerator, you actually realize that it has a factor of x minus 1. Okay, so it has a factor of x minus 1 and ax squared plus bx plus c. Okay, when I key calculator, it gives me a decimal. So if it has a factor of x minus 1, if my denominator has an x minus 1 as well, at the end of the day, it cancels each other out. So technically, this is my question. And I only have 2 brackets, which is why my final answer only has 2 fractions. Okay, so you don't usually see a or a constant being equal to 0 because that means that your entire equation is gone. Okay, so this is a special case. Next part, in part B, the question said hence. If the question said hence, it means you have to make use of part A. Even if your answer is correct in part 2 and you don't get, and you didn't use your answer in part A, you will not be given the full marks because you didn't make use of previous part. And the question explicitly said hence. Okay, so when we look at the questions, there's a slight difference. X cubed is now x to the power of 6. X is now x squared. All the x has been replaced with x squared. So naturally, you can identify that the pattern from here to here is that x is replaced with x squared. So in your answer in part 1, all you need to do is replace all the x with x squared and you'll get the answer. So since this was my answer in part 1, instead of writing x, I just need to write x squared. So it will be 2 plus 11 over x squared plus 3 minus 23 over x squared plus 4. Finish. Okay, so the key in this question for part 2 and how you link it to part 1 is that you have to make sure that you identify what is x replaced with. Because it's no longer x that you see, it's x squared. And please do not say that you want to factorize this using partial fractions, because it's going to be very tedious and long, because you're working with x power 6. So since the question said hence, make use of the previous part. Okay, I received a very good question over here that said if your denominator is power 2, shouldn't my numerator has power 1, based on the fact that my numerator and denominator always has a relationship whereby numerator has a degree that is 1 lesser than my denominator. So for this question, because it's a hence question, the answer came from the previous part. Okay, so when your answer came from the previous part, all you are doing is you're doing replacement. So you are not doing any substitution. You're not doing any partial fractions on your own. You are merely making use of the previous part. So when you make use of the previous part, afterwards, you'll realize that the rules will not always apply, which is, in this case, the rules didn't apply. Okay, because when you do substitution, you replace my x. If my numerator had no x to begin with, nothing to replace, so it will look a bit odd as from what we have always been working with, which is usually you have x squared at the bottom, you should have an x at the top. But because in this case, you're replacing, your rules don't have to always apply. You just have to suck in x and replace x with x squared. Okay, so when it's a hence question, when you're doing replacement, substitution, you don't have to be very conscious about this tip that I said just now, whereby the numerator has to be 1 lesser than the denominator. Okay, so only for special cases like this, for other cases, please always remember that tip. Okay, the special case here is that you are doing a hence question. So you are replacing x with another variable now. Okay, if no questions, okay, does anybody else have a question? If no question, can you give me a thumbs up? It's the last 12 minutes of the revision event already, so I'll just go through one last question, then we can conclude today's session. So, okay, I see the thumbs up already. Okay. Next. Okay, for the next question. Now you realize, how come my denominator is like that? My denominator is not factorized. All my previous question, all my denominators, they are factorized for me already, if you notice from the previous questions. So, this is when I say, you have to make use of polynomials, because my denominator is a polynomial, it's a cubic equation. So, what must I do? I have to factorize. So, part 1. Okay, first, you want to factorize, you must always define fx. Let fx to be equals to 2x cubed minus 9x squared plus x plus 12, which is my denominator over here. Next, to factorize, if you recall the polynomial question, when it's factorizing, you have to do the trial and error method. So you can actually use the calculator and find what are the factors of this straight away. So those that use the same calculator model as me, which is this fx96 over here, you can try pressing mode 3, 4, and you key in a equals to 2, b equals to 9. So this is a, b, c equals to 1, and d equals to 12. Okay, and you will realize that the calculator gave you a few answers. The calculator gave you x equals to -1, x equals to 4, and x equals to 3/2. Therefore, since I'll use the example, okay, I'll use x equals to 4. So what the calculator is doing here is it's solving the equation for you. It's telling you that when x is equal to 4, fx will be equals to 0, which means one of the factors has to be x minus 4. Because when you sub x equals to 4 into this equation, you will get 4 minus 4, which is 0. So this is when the trial and error method comes into play. You will write down, let x minus 4 be a factor. Okay? That's when your factor theorem comes in. Technically, we already know that this is a factor, but we still have to pretend that we actually use guess and check. And we are making use of the concepts taught in this topic to ensure that we can find the true factor. Okay, so all you need to do is sub in x equals to 4. You don't even need to press calculator, you already know that my remainder will be equals to 0. Okay, 100%, because you already know that x minus 4 is a factor. Then you conclude x minus 4 is a factor. Okay, now you must find the remaining roots. You either do long division or you do comparison. Long division is very simple and actually you don't need much practice for long division. So I'll go through on comparison because it is faster and it's easier to in the exam. Once again, this is a cubic equation. If I already have x, it means I must have a quadratic equation, which is ax squared plus bx plus c. So that when I multiply x squared and x, I'll actually get x cubed. Next, we always compare the highest power, which is x cubed. So comparing x cubed, on the left, you have 2. On the right, you have x times ax squared, which gives me 2a. Therefore, a is equals to 1. Okay, very simple, very fast. Next, after the highest power, you always compare your constant. So for constant is 12 on the left-hand side. On the right-hand side, it will be negative 4 times c, which gives me negative 4c. And therefore, c is equals to negative 3. Okay, last but not least, you want to compare b. You choose either x squared or x. So I'll choose x in this case. When you're comparing x, on the left, you have 1. On the right, to get 1, it will be x times c, which gives me cx. Followed by negative 4 times b, which gives me minus 4b. Okay, and since we know what c is negative 3. From here, you can get 4b to be equals to negative 4, which means b is equals to negative 1. Okay. Okay, wait, for this a, I write only, it's not 2a, it's just a. Because x times a, ax squared will just give me a. So a is equals to 2. Okay. So from here, you can conclude. So if you are lazy and you don't write down an entire equation, you can just write fx. Okay, that's the perk of defining fx. So I have fx to be equals to x minus 4 followed by 2x squared minus x minus 3. And this is a quadratic equation. So you can further factorize and have 2x minus 3 and x plus 1. Okay, so you must always factorize into 3 brackets because that is called factorizing completely. So this is the first part. We are only factorizing the denominator and if you realize it's actually very long already. So I can guarantee this question will actually be a lot of marks. Okay, so now I factorize already. Let me move on to the partial fractions part. So I'll use a new page because I need a lot of space. So in your question now, instead of writing 2 minus 3x, you can, instead of writing the fx in the denominator, you can actually write as a factorized form, which is x minus 4, 2x plus 3, followed by x minus 1. Okay, because we have already factorized in the previous part, sorry, x plus 1. Okay, so you make use of what we did, which is to factorize the denominator. And then you don't write fx anymore because you need to factorize your denominator. If you recall, partial fractions, the first few steps is to factorize denominator. Okay, then from here, you have 3 different brackets, which means you will have 3 different fractions. X minus 4 plus b over 2x minus 3 plus c over x plus 1. Okay, then we repeat the cycle all over again. Make the denominator the same, compare the numerator. So you have 2 minus 3x equals to a over 2x minus 3 and x plus 1 plus b over x minus 4, x plus 1 plus c times x minus 4 and 2x plus 3. So same thing, you always do elimination. These two, you let 0. So for this to be equal to 0, you must sub x to be equals to 4. So the entire portion here is gone because 0 times anything will just give me 0. So when you sub x to be 4, you have 2 minus 3 times 4 equals to a over 8 minus 3 and 4 plus 1. Okay, which gives me negative 10 equals to 25a. Okay, which means that a is equals to negative 2 over 5. Next, these two, x plus 1, you let to be equal to 0. Therefore, you sub x to be equals to negative 1. Okay, always remember you want it to be equals to 0. So there's a value of x that will enable you to have the bracket to be equals to 0. So on the left, 2 minus 3 bracket negative 1. So since x plus 1 is now equals to 0, you no longer have a and b. So it will just be c. Negative 1 minus 4 times negative 2 plus 3. Okay, this will give me 5 equals to negative 5c. So c is equals to negative 1. Okay, then for the last portion, we cannot, we can do one more substitution whereby you let 2x minus 3 to be equals to 0. Okay, 2x minus 3. Okay, you let 2x minus 3 to be equals to 0. So you will sub x to be equals to 3 over 2. So on the left, you have 2 minus 3 bracket 3 over 2. On the right, since these two are now equals to 0, I'm only left with b. So it will be b bracket 3 over 2 minus 4 and 3 over 2 plus 1. So on the left, you will have negative 5 over 2 equals to negative 25 over 4 b. Okay, which means b is equals to 2 over 5. So I get a, b, and c. My final answer will just be negative 2 over 5 bracket x minus 4 plus 2 over 5, 2x minus 3, followed by minus 1 over x plus 1. Finish. Okay, so remember when there's a fraction, your denominators just need to bring down. When you have a negative, you just need to put as minus, then positive. Can already. Okay, for this portion, you sub x equals to 4 because you want x minus 4 and here to be equals to 0. So that you can eliminate B and C. Okay, when you sub x equals to 4, x minus 4, it will be equals to 0. So same thing, over here, x minus 4 will also be equals to 0. So when you have a 0 in the bracket, b times 0, you will just have 0. So it means b and c is gone. Okay, so I think I've gone through what is needed for partial fractions now. So for part 2, you can actually just try on your own. It's just same thing as the previous part. You are replacing x with something. Okay, so now having said that, that will be the end of today's session. Before you go, there is a feedback form that we hope that you guys can fill up. So I'll flash on the screen now. Okay, you can scan this QR code to put your feedback in. So if you are done your feedback and you have nothing, no more question, you can leave the meeting, and thank you for coming to the session. Okay, you can actually find the solutions on our website. We will upload everything into the Google Drive soon when all the sessions are over. So you want to practice the rest of the questions, you can go ahead and practice them, and the solutions will be provided so you can check your work. Okay, and does anybody here have any questions for me? Okay, so please scan the QR code and share your feedbacks for this. And then afterwards, I will end the meeting. Okay, then I'll flash the solution again for the previous question. Okay, so the previous solution for the partial fractions part is over here. Okay, so for those with no more questions, you can actually leave the meeting already. Okay, solutions will be uploaded into the Google Drive link that I have sent. If not, it should be the Google Drive link will once again be shared into your all the emails that you sign up with. Or if not, it will be on the website. So you can find all the solutions in the website. Okay, so I will end the session now, and thank you for coming.